A key part of any VEX robot are gear systems in order to change the amount of output speed or torque of a standard VEX motor. Using the standard VEX gears, these systems are large and bulky and are often quite inefficient. The large gears make mounting difficult and assembly hard. They also tend to be very high friction and can skip or break easily. My team sought to fix this problem by creating a more efficient gearing system for VEX robotics. We started by drawing out designs in our notebook and then working through different possible gear ratios and different gear sizes to see what could fit in the box. We had the goal to make our gear systems no larger than the standard VEX 393 motor so that they could be easily integrated in a minimal space design. We drew inspiration from some of the gearing solutions used in larger robotic systems, specifically with large electric motors. These systems usually use self-contained gearboxes to create a gear ratio. These boxes keep all of the gears in a secure and easy to maintain location, and because they are mounted in a secure box, they are less likely to skip or become damaged. They are also easier to lubricate and maintain. We desired to mimic this sort of system and make it applicable to VEX robotics. Here is the result of our design, a self-contained gearbox that can be used in a variety of separate applications, including different ratios and locations in the VEX robotics system. It was important that we be able to create a large variety of gear ratios in order to accommodate all possible designs used in VEX robotics. To this end, we created 3 separate gearboxes. This one is a 3-to-1 ratio. We also created, in the same external box, a 2-to-1 ratio and a 5-to-1 ratio. All of these designs use the same external gearbox with only the gears inside changed. You can see here the gearbox blown up and expanded. The gears inside can be taken out, removed, and replaced with a different set of gears in much the same way that the gears inside a standard VEX 393 motor can be changed to accommodate different gear ratios. Here you see the gearbox fully disassembled. These gearboxes can be opened and have their gears removed. These gears can then be replaced with different ones to accommodate different ratios, in much the same way that the internal gears of a VEX 393 motor can be removed and replaced. This allows for the possible gear combinations of 2-to-1, 3-to-1, and 5-to-1. We recognized, however, that teams may not always want to increase the output torque of their motors, but may also want to do the opposite. So we wanted to allow for the opposite of these 3 gear ratios, that is, a 1-to-2, 1-to-3, and 1-to-5 gear ratios. When we designed these gearboxes, we were careful to make sure that the inputs and the outputs were opposite each other, and that the external gearboxes were symmetrical top to bottom. This means that the gearboxes can be flipped over, and by simply doing this, the internal gear ratio of the box is reversed. This has now opened up the possibilities of a 1-to-2, a 1-to-3, and a 1-to-5 ratio. While this solution is undoubtedly better than the current gear system in VEX, we were not quite satisfied. These 6 ratios did not represent all of the ones that teams may need. In this year's game, teams are often using 16-to-1 all the way up to 35-to-1 gear ratios. So we wanted to make it easily possible for teams to access any gear ratios they could possibly desire. To this end, we decided to ensure that the gearboxes could be stacked, one on top of each other, without having to move side to side or chain multiple boxes together as sprockets. To this end, we made sure that all of the screws laid flush to the gearbox when it was assembled, and that the gearboxes could easily be bolted together. Here you see an example of a 5-to-1 gearbox bolted to a 2-to-1 gearbox, allowing for a 10-to-1 ratio. This 10-to-1 ratio is, of course, reversible, meaning if you were to spin the other shaft, you now have a ratio that increases speed rather than increasing output torque. This stackable and combinable system allows teams a large amount of variety in choosing their designs. Here you can see an example of a 1 to 25 gearbox constructed using two 5 to 1 gearboxes and a standard VEX motor. The boxes are mounted to the motor using our custom designed base plate that is used as an adapter between a standard VEX motor and our gearboxes. The entire 1 to 25 gearbox is only slightly larger than the original motor itself. Having all of the gears self-contained makes for a stable and efficient system. This animation will show how the gearboxes can be assembled on top of a VEX motor and then stacked and attached to the VEX metal system. First, the base plate adapter is attached to the VEX motor with standard VEX motor screws. Next, the gearbox is placed on top of the base plate and bolted on using standard VEX bolts. A properly sized shaft is inserted between the gearboxes that are then bolted together. The final gearbox can then be attached to any piece of VEX metal. The gearbox attachment points are spaced so that they will work with a VEX metal system. To design this system, we used Autodesk Inventor's built-in gear making tool. We then assembled the gearboxes in Autodesk Inventor and used Inventor's explosion and animation software in order to create a demonstration of how the gearboxes can be assembled. We think that these gearboxes are a vast improvement over the current VEX system and could be of great benefit to all teams in any VEX game by allowing them to make gear ratios quickly and easily in a robust and self-contained system. It enables much more complex and creative designs in other parts of the robot without having to worry about transmissions or gear ratios.